In the last video, we discussed the application of L'Hopital's rule, and we discussed the intermediate form 0 over 0 and the application of L'Hopital's rule in this case. Afterwards, we solved an example using that intermediate form, and today we're going to discuss the intermediate form infinity over infinity. So, I like the intermediate form 0 over 0. First of all, we have to check if the expression f of x over g of x gives us infinity over infinity, and then we can use L'Hopital's rule. So the best way to start, in my opinion, is to solve an example. So let's say we have the limit as x approaches infinity of x squared minus 3x plus 5 over 7 plus 2x minus 3x squared. Okay, so here we replace the x with a infinity. We can see that we will get the form infinity over infinity. Here, now you know that infinity is not actually a number, but we can think of it as that it has a very large value. And here, since we have infinity squared, that will be much bigger than minus 3, either of plus 5 or minus 3 infinity. So there is no reason to, of course we cannot get infinity squared, but this is the value of the expression in the numerator, and in the denominator we have the same case. So if we apply L'Hopital's rule, we need to find first the derivatives. You can think of these two expressions as separate functions. So now the derivative of x squared minus 3x plus 5 is 2x minus 3, and the derivative of 7 plus 2x minus 3x squared is 2 minus 6x. Okay, now if we apply, if we replace the x for the infinity, what will we get? We will get again the intermediate form infinity over infinity. So, as we said in the previous video, we have to use L'Hopital's rule again, and we use this technique until we get a proper value. So the derivative of 2x minus 3 is equal to 2, and the derivative of 2 minus 6x is equal to 6, and we'll get minus 1/3. And this is the limit of, as x approaches infinity, of x squared minus 3x plus 5 over 7 plus 2x minus 3x squared. Let's solve another example. I will show you something different now. First of all, if we get a form like infinity times 0, or something like infinity minus infinity, we need to convert this form to get infinity over infinity. For instance, if we have the limit as x approaches infinity of, let's see, x times sine of 1 over x. Now here, if we replace the x's with the infinity sign, we will get the form infinity times 0. Since here 1 over infinity we get 0. So what we can do is we can replace the x with 1 over x, and if we evaluate this we'll get the same value. So if we replace this instead of x, we'll get, let's see actually what we will get, 1 over x times sine of 1 over x. Now here we replace the x with the infinity sign. We'll get 1 over infinity, which is 0, and we'll get 1 over 0, which is equal to infinity. Okay, and if we use L'Hopital's rule now, we will see, actually we can rewrite this as sine of 1 over x over 1 over x, and here we will get in this expression 0, and here we will get 0 if we replace x with the infinity sign. And if you use L'Hopital's rule, we will get, let's see, the derivative of sine of 1 over x is equal to cosine of 1 over x, and here we want to use the chain rule, and the derivative of 1 over x will be equal to minus 1 over x squared. Is that right? Yes. Times minus 1 over x squared, and in the denominator we'll get the same thing actually, and these two things cancel out, and we'll get cosine of 1 over infinity, which is equal to 0, so cosine of 0 will be equal to 1. And in the next few videos we're going to solve some problems using L'Hopital's rule.